Here's f of x equals negative 3 over x minus 2 plus 1. This is going to be a flip because of the negative sign. So instead of looking like this, it's going to look like that. It's just going to flip it. Each side flips. And then this one has a vertical stretch of 3. It approaches the asymptotes 3 times faster than the parent function. Because it's x minus 2, it's a horizontal shift of 2 right. And because it's plus 1, it's a vertical shift of 1 up. Vertex, never heard of it. Remember, for the parent function, y equals 1 over x, the vertical asymptote is x equals 0. The horizontal asymptote is y equals 0. And these just shift them. So I shifted it 2 to the right. So the horizontal or vertical asymptote is going to be x equals 2. So normally x equals 0. It goes 2 to the right, x equals 2. That's because of that x minus 2, the minus 2 part. Horizontal asymptote usually is y equals 0. And now it's shifted up 1, so it's y equals 1. The domain is all the real numbers except that vertical asymptote. So it's all reals such that x does not equal 2. All reals except x equal 2. And the range is all real numbers. You can put negative infinity to infinity. Now I'm going to draw it. Vertical asymptote x equal 2. Horizontal asymptote y equals 1. Remember, this is flipped. And so I'll just graph one point and draw it in near the asymptote. Let's say at x equal 1, this is 3 over 1 minus 2, which is 3 over negative 1. Negative 3 over negative 1 is positive. 3 plus 1 is 4. So at x equal 1, this is at 4. Good enough. And then it has to get closer to the asymptote without ever touching it. Good enough. And then I'll go at x equal 3. 3 over 3 minus 2 is 3 over 1 is 1. Negative 3 over 1 is 3. Negative 3 plus 1 is negative 2. So at x equal 3, this is at negative 2. I have to find it. So it's like down there. And it goes like that. I think I did that wrong. At x equals, well, I don't want to do x equal 2. I do x equal 3. Yeah, 3 minus 2 is 1. Yes, 3 over 1 is 3. Negative 3 plus 1 is negative 2. So x is 3. I did have it right. X is 3. It's at negative 2. So that was right. You can do a couple of points just to figure out what it should look like, but there it is. So you've drawn it. And that's all the questions answered. Now I'll do one more. Let me do 1 over x plus 4 plus 3. So, number 1, there's no stretch. Here's the horizontal shift. It's 4 to the right. Horizontal shift 4 to the left, rather. It's plus 4, so it's 4 to the left. A vertical shift of 3 up. The vertex, vertical asymptote. Well, again, normally the vertical asymptote is x equals 0, but I've shifted 4 to the left, so it's x equals minus 4, shifting that asymptote 4 to the left. The horizontal asymptote usually is x equals 0. This is shifted 3 up, so it's y equals 0 rather, so it's y equal 3. Domain, all real numbers such that x does not equal minus 4. The asymptote is excluded, and the range, all real numbers. So let me draw in the asymptotes, x equal minus 4. And the horizontal asymptote, y equals 3. Well, they didn't give me much room to draw this on this graph. And so let me do a couple of points. Let's try -3 at x equal -3. -3 plus 4 is 1. 1 over 1 is 1 plus 3 is 4. So at x equals -3, y is 4. So it's something like that. It's got to approach the asymptotes. And I'll try -5. -5 plus 4 is -1. 1 over -1 is -1 plus 3 is 2. So at -5, it's at 2. And then I've got to approach the asymptotes like that. So that's it. That's how you handle these shifts.